All right, probability distributions. Construct a probability distribution of X given this scenario. One thing we need to understand about probability distributions is that they got to satisfy both of these conditions over here. Each probability must be between 0 and 1, right? And then the sum of all possibilities needs to be equal to 1, right? This must occur. If we're talking about all possibilities, all outcomes that could occur, 100% chance if we're including them all. So 1, okay? Each probability in between 0 and 1, meaning you might have a 50% chance, a 50% chance. Well, both of those are going to be between 0 and 1, 50%. Okay? Construct the probability distribution of X when a coin is tossed twice. So we got this coin heads and tails. Nothing special about the coin, just a head side, tail side. And if you're going to flip it twice, let X be the number of heads we observed. So what I'm going to ask you is this. What are the possibilities? What are the outcomes that could occur, right? X could be 0 if we had a tails and a tails. So never will you see a heads. Tails, tails on both flips. But X could be 1 if we got a tails the first time, heads the second time we flipped, or vice versa. Maybe we got heads the first time, tails the second time. So now we've got 1 time seeing heads. That could happen twice. 2 different scenarios where that occurs. Or maybe we just get lucky and we get heads both times. So X could be 2 in the scenario of heads and heads. So now that we have this written out, we've got the possibility of never seeing heads when we flip that coin, the possibility of only seeing it 1 time. That means maybe the heads popped up on the second flip, maybe the heads popped up on the first flip, or we just get heads both times, we got lucky and we see it twice. Okay, so now that we have that, we need to make a probability distribution. So what that would look like is just a table of values, right? So you're gonna have X here, and then we're gonna say P, X here. Now, what's my probability of it happening 0 times, of X being 0? Well, 1 out of 1, 2, 3, 4. There's 4 different possibilities there. 1 out of 4 would be a 25% chance. Okay? What's our probability of X being 1, only seeing heads 1 time? Well, because that can happen 2 different ways, that would be 2 possibilities out of 1, 2, 3, 4 outcomes. Well, 2 out of 4, that's a 50% chance. All right? What's the possibility or probability of it happening and seeing heads twice? Same as seeing it 0 times, 25% chance, because there's only 1 scenario where that occurs, and that's where you flip heads, and then you flip heads again, okay? Twice. So this right here is gonna be your probability distribution, okay? Oh man, went right through that number there. Okay, so now that we've got the probability distribution set up, sorry about that. Not that that makes it look much nicer, but you guys get the idea. Okay, now we're being asked to find the probability that at least 1 head is observed. Well, notice here, do you see heads at all? No, you never see heads, it's tails, tails. So we're not counting this one, but we need to include this one here, as well as this one here, because in any one of those 3 scenarios, you would see heads at least once. So basically what that's asking is when X is greater than or equal to 1, right? Well, that means we got to count this one and we got to count this one. So we're just going to add our 2 probabilities together. That'd be 0.5, 50%, plus 0.25, 25%. Combining those is going to give us a 75% chance of seeing heads at least 1 time. And that's how you would break down a problem like this. So once again, make sure that any probability distribution, you've got to satisfy both of these conditions. Okay, that has to be the case. Make your distribution tables. and then use what they're asking based off of the question. In this case, find the probability that at least one head is observed. At least one head. So it could be one or it could be two. You see it once or you see it twice. So anything above one, I include the one and the two. That means I'm adding both of these numbers together to get my total probability. Okay? Hopefully this makes sense. Study hard and good luck on your upcoming test.